Hello, this is Ishao from group 77. The rest of my group members are 建凡霍、云浩度、一心讲, and Celine Zhao. I'm going to introducing our project to you. From 2020 to 2021, everybody's life has completely changed by the COVID-19 pandemic. The number here shows that since April 2020, COVID-19 patients has existed 20 million, while the death toll has reached 5 million around the world. To prevent further damage from the virus and to provide the best hope of ending the pandemic, millions of vaccines are being delivered globally through the global access to COVID-19 vaccines facility. And yet, still many people choose not to take COVID-19 vaccine, even though vaccines are completely free. If we want to improve the immunity of individuals, we must study the factors that affect vaccination rates. That's why we started the project. This is a graph shows vaccination rate by region with the US. We have also brought our research questions. Did each state economy made an impact on COVID-19 vaccination coverage rate? As we searched, collected, and examined the data, we picked out the data we need and sort and rename them. Then we get DF vaccine, DF population, DF income, DF GDP, and DF. Finally, we get clean data as shown in this picture. This slide shows our result to find the basic relationships. From the scatter diagram above, we can see that there are some trends between our data. It also looks like there are some outliers. In order to further confirm the relationship between our variable, we can make outliers analyze and rearrange our data to check whether the data has outliers and decide whether we need to delete any outlier. In our data cleaning, we have found that outlier in the diagram of total vaccinated in 1,000 outlier analysis are California, Florida, New York, and Texas. However, we cannot eliminate these 4 states' data because they are part of the 51 state in the US. If we remove them, we will miss data for these 4 states. So we just keep them. We considered population to be probably the confounding variable that may affect both states' economy and vaccination coverage rate. We want to determine if there was relationship between these variables. It seems like the vaccination coverage rate doesn't have a positive relationship with the population. In our diagram, all the points are hovering next the x-axis near the top of the graph. There is also an extreme outlier. From the above graph, we initially conclude that total vaccinated and population doesn't have a linear relationship. Then we back to our analysis on relationship between vaccination coverage rate and personal income. And from this graph, we find that there is a positive linear relationship between the increasing rate and vaccinated population and personal income. To see their relationship closely, we use the in plot to draw the line of their relationship. Now we analyze the relationship from this new graph. We can see there is a positive linear relationship between the increase rate in vaccinated population and personal income. This also suggests that individual income has a positive impact on increasing rate in vaccinated population for each state. Increase rate in vaccinated population increases when the state has higher personal income. Our research question is to check if each state is contributing to the spread of COVID-19. We gather data from the government sites so we can get a broader view. Our goal is to analyze the data for a specific season so we can get a broader view of the number of people who get vaccinated during that period. Even though our project was able to conclude that personal income and vaccination rate have a positive relationship, we still need more information to make a more complete statement. Variables like government policy, individuals' age, and much more information are needed to be included to make a complete statement. And that's all. Thank you for listening.